Good morning, students. Myself, I am Dr. SP Yeole, HOD, is DSM Junior College, Palghar. Students, we continue the topics of elements of group 16, 17, and 18. Last time we have discussed the methods of preparation of oxygen as well as some structures of the dioxygen in that hypohalous acid, halous acid, and halic acid. As well as we'll see the diagrams regarding the preparation of hydrogen oxygen as well as one industrial method also we saw. Now, today we want to start physical properties of dioxygen. In the physical properties of dioxygen, dioxygen is colorless and odorless gas. Means we cannot see the color, we can take the odor, but we cannot feel. That is odorless. Dioxygen is sparingly, means little bit soluble in water. About 30.8 cm cube of oxygen dissolves in 1 liter, means 1000 cm cube of water at 293 Kelvin. A small amount of dissolved dioxygen is sufficient to sustain marine and aquatic life. This is very most important physical property of dioxygen, which is beneficial for fish as well as other aquatic animals. It can be liquefied at 90 Kelvin and freezes at 55 Kelvin. Oxygen has three stable isotopes: oxygen 16, oxygen 17, and oxygen 18. So these are the stable isotopes of the oxygen. Molecular oxygen O2 exhibits in paramagnetism, and paramagnetism that you learn better in the nature of the chemical bond. Chemical properties of oxygen in that reaction with metals. The oxygen directly reacts with almost all metals except gold, platinum, and forms their oxides. Example: 2 calcium plus oxygen, it gives twice calcium oxide. Then 2 aluminum plus 3 O2, it gives out twice alumina, Al2O3. Then reaction with non-metals. The oxygen reacts with non-metals except noble gases to form their oxides. After calcium, aluminum will continue the reaction of the carbon and phosphorus. Carbon reacts with oxygen, it gives carbon dioxide, and phosphorus P4 reacts with 5 molecules of oxygen, it gives P4O10, or you can write 2 molecules of P2O5 also. Now, chemical properties of dioxygen we'll see. In that reaction with some compounds, 2 ZNH zinc sulfide means blend plus thrice O2. By heating, it gives 2 molecules of zinc oxide plus 2 molecules of sulfur dioxide. Then methane plus 2 oxygen, it gives carbon dioxide plus 2 molecules of water. Then 2 sulfur dioxide plus O2 in presence of V2O5 catalyst, means vanadium pentoxide catalyst, it gives 2 molecules of sulfur trioxide. Then 4 molecules of HCl plus O2 in presence of copper chloride catalyst. By heating, it gives 2 molecules of chlorine and 2 molecules of water. So these are the reaction of uh, these elements and compounds with the oxygen, and it can be used the particular product also along with some byproducts. Later on, uses of dioxygen, where we can it can be used. Dioxygen is important for respiration to sustain animals and aquatic life, that already we discussed. It is useful in the manufacture of the steel. It's very important use. It is used in oxyacetylene flame for welding and cutting of the metals like acetylene, so it can be works for this welding and cutting of the metal. Oxygen cylinders are widely used in hospitals, that I said already, and it is high altitude and flying for mountaineering or mountaineering. It is used in combustion of fuels, for example hydrogen. In liquid, oxygen provides tremendous misthrust energy in rockets. So when a rocket is launched, that time such type of liquid fuel can be used. It has the better combustible power. Simple oxides. A binary compound of oxygen with another element is called as oxide. Oxides can be classified into acidic oxide, basic oxides, amphoteric oxides, and neutral oxides. So these are the main four types of the oxides. One by one we'll discuss. First of all, acidic oxides. Acidic oxides are those in which or which can be dissolved in water to give an acid or reacts with base to give salt is called as acidic oxides. Example: sulfur dioxide, sulfur trioxide, carbon dioxide, nitrogen pentoxide, Cl2O2 chlorine oxide, etc. Sulfur dioxide, when water combines with water, it gives H2SO3. Later on, sulfur dioxide reacts with base like NaOH. It gives Na2SO4 mixed with with molecule of water. Generally, what happens? These oxides of the non-metals are acidic in nature. That's why these are called as acidic oxides. Second type is basic oxide. An oxide which dissolves in water to give base or alkali, which can be reacts with acid to give salt, is called basic oxides. Example: sodium oxide, calcium oxide, barium oxide, etc. Calcium oxide plus water, it gives calcium hydroxide. Similarly, barium oxide with HCl, two molecules of HCl, it gives barium chloride along with water. Then amphoteric oxide. Oxide which reacts with base as well as which reacts with acid to form salt is called amphoteric oxide. Amphoteric means, remember, it has dual nature. What dual nature? Like acidic as well as basic. Example: alumina, Al2O3. Al2O3 with 6 molecules of aqueous NaOH with 3 molecules of water liquid, it gives 2 molecules of Na3AlOH6. Now, this one formation of the salt is here, and whenever acidic oxide reacts with water, we can get this reaction with base. Similarly, this alumina plays the role of basic oxide also when it combines with acid with 9 molecules of water, and in product side it gives 2 molecules of Al H2O6 3 plus and 6 Cl minus aqueous. Remember, acidic oxide combines with base gives salt, and basic oxides combined with acid gives salt. So with which compound it going to treat? So its nature that can be decided as whether it is acidic oxide or basic oxide. Then next type is neutral oxide. Neutral oxides which are neither acidic nor basic. That's why these are called as neutral oxides. Example: carbon monoxide, nitrogen monoxide, nitrous oxide, etc. So these are the best examples of neutral oxides. Now we'll see the next compound or next molecule, that is of ozone. Structure of ozone that we can discuss first. Structure of ozone has the 3 oxygen atom. That's why it has the formula O3. But steric hindrance means crowding of the electron or crowd of the electron toward the central oxygen that can be prevent it from forming a triangular structure. Each oxygen forms only one bond, with the remaining negative charge being spread throughout the molecule. The two oxygen-oxygen bond length in the ozone molecule are identical, that is 128 pm, and the oxygen-oxygen-oxygen bond angle of single is of about 117 degree. That you can observe in this diagram. In this diagram, here it shows the resonance hybrid of the two canonical form. In canonical form, you observe that distribution of the electrons, and by that we can get the finally resonance hybrid structure. How? Here, first molecule of ozone. This ozone with the 6 electron with negative charge, then ozone with two electron with positive charge, and ozone with double bonded, means oxygen with double bonded in this ozone, which has the 4 electron. So 4 electron means these are electron deficient. This is also electron deficient, but as compared to this one, here this one is the electron rich. Negative means electron rich, it has a 6 electron. 2 electron from this easily transfer, and from this electron can be withdrawn over here. In this way, this one, then this one. Now here, these electrons are transferred, that's why we'll get here a double bond. And from this one electron, means pi bonded electrons are shifted over here, and that's why we can get here oxygen negative. Similarly, this electron can be returned back in this way. So here these electrons can be ranging between this region to this region. That's why we can get in the final structure. Here this electron can be ranging between this region to this region. That's why it shows such type of hybrid structure. Hybrid means mixed structure, that is of resonance hybrid structure of the ozone. Now here bond angle of the oxygen is of 117 degree, and the bond length of the oxygen is of 128 pm picometer. Now why ozone layer is called as ozone umbrella? Oxygen in the upper layer or upper atmosphere absorb energy in the form of ultraviolet light and changes to atomic oxygen, which can be combined with molecular oxygen to form O3 ozone. Oxygen O2 in presence of UV light, it gives carbon, oxygen plus oxygen, and O2 plus oxygen, it gives ozone. So here in this way, we can see here surface form. This ozone can be uh, remain at the upper surface from the harmful ultraviolet UV radiation. That's why it is called as ozone umbrella, which is very protective for the human being also as well as atmosphere also. Then how to prepare ozone? Ozone is prepared in the laboratory by passing silent electric discharge principle through pure and dry oxygen in an apparatus called ozonizer. As the conversion of oxygen to ozone is only the 10%, the product is known as ozonide oxygen. It is an endothermic process. Endothermic means it can be absorbed heat. How much it can be absorbed? Plus 142 kilojoule per mole heat can be absorbed in this process. So by silent electric discharge principle, when three molecules of ozone gas reversibly it gives two molecules of ozone. From three molecules of oxygen gas, it gives two molecules of ozone. And for that delta H, change in enthalpy is plus 142 kilojoule per mole amount of the energy is given out. That's what is of endothermic type of reaction. In this reaction, here how it can be performed. In this assembly, you can see dry oxygen can be passed through this one. Later on, in presence of dilute sulfuric acid, we can perform this reaction and through ozonide oxygen. Here, it can be liberated here, ozonide oxygen that you can see over here. And below this one graph is there, how it is endothermic. So in reactant side, this much amount of the energy, and as the reaction is in progress, then here this reaction graph shows that here product is formed. So between this one, what is the delta H that can be find out? That is of 298 kilojoule per mole, and it is of the total difference is of 142 kilojoule per mole. So it is the endothermic type of reaction. Here three oxygen gas by silent electric discharge principle, it can be used to ozone molecule or gas. Then physical properties of ozone we'll see. Pure ozone is a pale blue gas, dark blue liquid, and violet black solid. Then ozone has the characteristic smell. When inhaled in concentration above 100 ppm, it causes nausea and headache. It is diamagnetic in nature. Now chemical properties also we'll see. In chemical properties of ozone, first of all we'll see oxidizing property. Ozone is a powerful oxidizing agent as it easily decomposes to liberate nascent oxygen. Reaction will see ozone it gives oxygen plus nascent oxygen. Then ozone oxidizes lead sulfide to lead sulfate and iodide ions to iodine. PbS lead sulfide solid plus 4 oxygen 4 ozone gas it gives plus PbSO4 solid plus 4 O2 gas. Then in next reaction we'll see here twice Ki potassium iodide aqueous plus water liquid plus ozone gas it gives twice KOH aqueous plus I2 plus oxygen plus nascent oxygen gas. Then ozone oxidizes nitrogen oxide and gives nitrogen dioxide. How? Here nitrogen monoxide gas plus ozone gas, it gives nitrogen dioxide gas plus liberation of the oxygen gas. So in this way, we can prepare ozone as well as this oxidizing property also I discuss. Then bleaching property. In the bleaching property, here ozone acts as the good bleaching agent due to its oxidizing nature. Ozone gives oxygen plus O2. Colored matter plus oxygen, it gives colorless matter. And what the oxygen will see, so it has the bleaching action. So this is the bleaching property. Ozone bleaches in absence of the moisture, so it is also known as dry bleach. Then reducing property. Ozone reduces peroxides to oxides. H2O2 plus ozone, it gives H2O plus twice O2. Barium dioxide plus ozone, it gives barium oxide plus 2 oxygen. Then fourth point we'll see ozone depletion. Thinning of ozone layer in upper atmosphere is called ozone depletion. The ozone O3 layer in the upper atmosphere, it can be absorbed harmful ultraviolet radiation from the sun, thus protecting people on the earth. So it's very most important property of the ozone. Then depletion of ozone layer in the upper atmosphere is caused by nitrogen oxide release from the exhaust system of car or supersonic jet aeroplanes. So that reaction is nitrogen monoxide gas plus ozone gas. So it gives NO2 gas plus O2 gas. So in this way, there is much more pollution. Depletion means thinning of ozone layer that can also be caused by chlorofluorocarbon mist freons used in aerosol and refrigerator and their subsequent escape into the atmosphere. So it is also one of the most danger. Then depletion of ozone layer has been most power, most pronounced in polar regions, especially or Antarctica. In that, ozone depletion is major environmental problem because it increases the amount of the ultraviolet radiation that reaches Earth's surface. Thus, it can be causes an increase in the rate of the skin cancer, eye cataracts, and genetic as well as immune system damage among the people, which is most dangerous for human life. Later on, we'll see uses of the ozone. Where we can use ozone. Ozone normally it is used for air in purification at crowded places like cinema halls, tunnels, railways, as well as in the most populated area. So this is the most important property of ozone. Second point I want to discuss in that in sterilizing drinking water by oxidizing all the germs and bacteria. For bleaching, ivory, oils, starch, wax, and delicate fabrics such as silk, as well as in the manufacture of synthetic camphor, potassium permanganate, etc. In that we can use the ozone. Students, uh, next topic is our compounds of sulfur that we'll see in the next lecture. Till that time, you take care, stay home, stay safe. Thank you. God bless you.